Hello, welcome to the Cisco CCNA preparation guide. We're still looking at this the Cisco document here. We've just covered unicast, anycast and multicast addresses. So let's move on. So what's new in IPv6? So this figure here summarizes the parts of the configuration that are similar to IPv4, which include a static config in DHCP. It also shows the parts that are new to IPv6, including stateless configuration and temporary addresses that are auto-negotiated. So here you can see, similar to IPv4, you can have manual configuration, and your hosts can still request DHCP from a DHCP v6 server and get a DHCP v6 reply. New in IPv6, you have the stateless configuration, which you have the router solicitation and the router announcement, and auto-generated pseudo-random numbers, which is RFC 3041. And you have an IPv6 address, which, as it says here, is a /64 prefix and random 64-bit. So address management and assignment. There are 4 ways in total to configure a host in IPv6. You have the static configuration, similar to IPv4, the host address, the mask, the gateway, they're all manually defined. You have a stateless auto address configuration, or a SLAC address, SLAAC. In this case, the host autonomously configures its own address. Router solicitation messages are sent by booting nodes to request a router advertisement. Request router advertisements. That's probably a better way to say it, not advertisements. RAs for configuration. So I can't even speak tonight. For configuring the interfaces. I wouldn't worry too much about these RFC things. They don't usually come up in the exam. So stateful DHCP v6. The host uses DHCP to get its IPv6 address. This address management is similar to IPv4 behavior. You still have timeouts, you still have lease period, that kind of thing. You have stateless DHCP. The host uses SLAC and also DHCP to get additional parameters such as TFTP servers, wins, etc. The configuration choice relies on RA flags sent by the router on the LAN. And static configuration. As in any IPv4 network, the host address can be statically defined. In this case, IPv6 addresses, masks, and gateways addresses are manually defined on the host. Static addresses configuration is typically used for router interface configuration, but it's not likely to be used by host on IPv6. So stateless auto configuration, stateless address auto configuration. Nodes can use IPv6 stateless address auto config to generate addresses without the necessity of a DHCP server. IPv6 addresses are formed by combining the network prefixes with an interface identifier on interfaces with embedded IEEE identifiers. The interface identifier is typically derived from the IEEE identifier. A little tech tip here. There may be concerns regarding the use of non-changing interface identifiers such as the IEEE identifier, because it's possible for that identifier to be used to correlate seemingly unrelated activity. Using DHCP to obtain the addresses is one way to address those concerns. And it also promotes easier deployment as well. The address auto config feature is built into IPv6 protocol to facilitate internet-wide address management that enables a large number of IP hosts to easily discover the network and get new and globally unique IPv6 addresses associated with their location. The auto-config feature enables plug-and-play internet deployment for newer customer devices, such as cell phones, wireless devices, home appliances, and so on. And as a result of that, network devices can connect to the network without manual configuration and without any service, such as a DHCP server. A router on the local link sends network type information through RA messages, such as the prefix of the local link and the default router in its router advertisements. The router provides this information to all nodes on the local link as it's shown here. So here's the router, it's advertising RA messages, and at boot time IPv6 hosts build a link local address and then its global addresses from RA. auto configuration with no collisions, and offers plug and play. After that, the host can then build its address by appending the host identifier to the /64 prefix received from the router, and as a result of that, an Ethernet host can auto-configure itself by appending its 48-bit link layer address, its MAC address, in an extended universal identifier, which is an EUI 64-bit format, to the 64 bits of the link prefix advertised by the router. Windows Vista and 7 don't use the EUI64 technique by default when forming their interface identifier. Randomized addresses are generated usually for non-temporary auto-configuration addresses, including public addresses, and the link locals addresses are used instead of the EUI64 addresses, as shown in Figure 3. It's also good for easy renumbering as well. In an IPv6 network, the auto-configuration feature makes renumbering an existing network simple and relatively easy compared to IPv4. The router sends a new prefix from the new upstream provider in its router announcements, and the host in the network automatically picks the new prefix from the router advertisements and then uses it to create a new address. As a result, the transition from provider A to B becomes manageable for the network operators. So stateful DHCP v6. Many enterprises currently use DHCP to distribute addresses to their hosts. Pretty much most of them do, to be honest. IPv6 can be deployed with the same DHCP mechanism. The process for acquiring configuration data for a client in IPv6 is similar to that in IPv4. However, DHCP v6 uses multicast for many of its messages. Initially, the client must first detect the presence of the routers on the link using neighbor discovery messages. If a router is found, then the client examines the router advertisements to determine if DHCP should be used. If the router adverts enable the use of DHCP on that link, disabling auto-configuration flag and enabling the management flag in RA messages allows the hosts to use DHCP v6 to obtain an IPv6 address. Then a client starts a DHCP solicitation phase to enable a DHCP server as shown here. You can see the DHCP solicitation message and then a flag off as well. So last but not least, using DHCP v6 provides the following benefits. It provides more control than serverless/stateless autoconfigs, and it can be used concurrently with stateless autoconfigs. It can be used for renumbering. It can be used to automatically domain name registration of hosts using dynamic DNS, and it can be used to delegate IPv6 prefix to leaf customer premise equipment routers. So stateless stateless DHCP v6 normally combines stateless auto configuration for address assignments with DHCP v6 exchange for all other configuration settings. In this case, DHCP v6 is only used for the host to acquire additional parameters such as TFTP servers, and a DNS server, and so on and so forth. A host builds its address by appending the host identifier to the /64 prefix received from the router and then issues a DHCP solicit message to the DHCP server as it's shown here. So when it comes to plan considerations, IPv6 is significantly larger than the IPv4 address space, which enables lots of flexibility in how you can define logical and practical addressing plans. You can assign a subnet prefix based on various logical schemes that involve factors detailing an IPv6 addressing guide on additional factors that pertain to IPv6, such as existing IP address schemes, translating an existing subnet number into IPv6 IDs, and translating a VLAN ID into an IPv6 subnet ID. redesigning your IP address schema, which would mean allocating IPv6 addresses according to your needs. When redesigning IPv6 addressing schemas, you can allocate according to your need. Such logical addressing plans have the potential to simplify network operations and service offerings, as well as network management and troubleshooting. The addressing plan must take the following into consideration: prefix aggregation. The larger IPv6 addresses can lead to larger routing tables unless network designers actively pursue aggregation. Network growth. It's important to design the address infrastructure to take network growth into account, and the use of unique local addresses, RFC 4193. As IPv4, there is private address space within IPv6. The main difference is that IPv4, every organization has the same private address space to choose from. In IPv6, the address space is just for the one network and is globally unique. This private address space can be used to address devices and services that don't need to connect to the internet.